Hello, my little mathematicians. Today, we're going to review equations and inequalities. So first off, remember that we made the problems pretty simple, that we know you can solve them in your head. So that way you can really focus on showing the steps for when they get harder. And then just kind of check yourself if yes, okay, I know that that's the right answer. And that way, again, you're solely focusing on the steps because that's what we're going to be marked on is, did you show the steps correctly? So first of all, I like to draw a line down from my equal sign to separate the variable from the other side. Okay, now you focus on where your variable is and you want to isolate it, which means you want to get rid of the thing that's preventing it from being by itself, that plus 2. Well, what's the inverse of plus 2? Minus 2. Now you have this cancel, and a is by itself, which is what we wanted. But whatever you do to one side, you have to do to the other. Now, 62 minus 2 is 60. So you get a equals 60. And the reason these canceled is because 2 minus 2 is 0, and a plus 0 is just a. And then again, remember, whatever you do to one side, you do to the other. So when I simplified this, I got 60. And if you're feeling unsure about yourself, you always plug it back in to check, which means you write the original equation, substitute in what you think the answer is. So I replaced a with 60, and then you simplify. 60 plus 2 is 62. Bring down your equals, bring down your 62. You get a true statement, so you know that a equals 60 is the right answer. So you can put a equals 60 or just 60. Okay, for the next one. Again, I want to get my variable by itself. So what's preventing it from being by itself? This minus 4. And the inverse of minus 4 is to add 4. Whatever you do to one side, you do to the other. Well, 4 minus 4 is 0. Those cancel. So now you have b plus 0 or just b. And on the other side, 40 plus 4 is 44. Okay, plug it back in. A lot of times before I plug it back in, I actually like to write my answer here, because sometimes the mistake, like on the problem before, some people might put 62 as the answer for the previous one. 62 wasn't the answer. That was just the true statement that we ended with when we plugged in the answer of 60. Okay, so again, before I check it, sometimes I like to put that answer in the answer column, and then I check it. B minus 4 equals 40. Replace b with what you think it is. I think b is 44, so that's what I replaced it with. And now I simplify. 44 minus 4 is 40. Bring down your equals, bring down your 40. That's a true statement, so then I don't have to erase this and retry. I can move on to the next problem. The next one says c plus 5 is 19. To get c by itself, you do the inverse of plus 5, which is to subtract 5. Now those cancel, and you have c plus 0 or just c. And again, they cancel because 5 minus 5 is 0. On this side, 19 minus 5 is 14. So I think c is 14. And if you're typing it in the computer, you'd probably just put 14 because something might flash up of, please only type numerical values, meaning just type 14, just the number. Okay, and then I like to check it. C plus 5 equals 19. Replace c with what I think it is. 14 plus 5 is 19. Bring down your equals, bring down your 19. This is a true statement, so then you can feel confident and move on to your next problem. Now this one is a division problem, and it's a lot easier if we get in the habit of rewriting it as a fraction. So whatever comes first goes on top, and then whatever comes second goes on the bottom of your fraction. Now it's easier to show your inverse step. What's the inverse of dividing by 3? Multiplying by 3. And then you can see that these 3's cross cancel and they become 1, right? Because 3 divided by 3 is 1. This 3 divided by 3 is 1. Now you have 1 times d, which is just d. But whatever you do to one side, you have to do to the other. Since I multiplied this side by 3, I want to multiply this side by 3 as well. And then 12 times 3 is 36. I would write that in the answer column and then check my answer. d over 3 or d divided by 3 equals 12. I think d is 36, so replace that. And then 36 divided by 3 is 12. Bring down my equals, bring down my 12. That is a true statement. 12 does equal 12. So I know that 36 was indeed the right answer. With confidence, I can move on to the second problem. Okay. Now, why don't you guys get in the habit of pausing the video, trying the problems yourself, and then unpausing and coming back to check yourself. Okay, so now if you're back with us, again, remember we suggested that if you have a division problem, rewrite it as a fraction. Whatever came first is on top, whatever comes second is on the bottom. And then I want this 4 to cross cancel, so I'm going to multiply it by a 4 so that those cancel and become 1. Whatever you do to one side, you have to do to the other. So I'm going to multiply that side by 4 as well. Now 1 times e is just e. E is up by itself. And then 8 times 4 is 32. So now I have e equals 32. That's what I think the answer is to number 5. And then just because I want 100% on my test, I'm going to check it. And it's good practice for later, for when the problems get harder, because you're going to want to check those. And so you want it to be second nature of how to check something. 32 divided by 4 is 8. Bring down your equals, bring down your 8. That is a true statement. So then you're like, yes, okay, 32 was right. Now for this one, I'm going to draw a line down again. And 5 times something equals 45, because when two numbers are touching with no sign between them, that means they're being multiplied. What's the inverse of multiplying? Dividing. Whatever you do to one side, do to the other. Well, 5 divided by 5 is 1. So you have 1 times f, or just f. And then simplify, 45 divided by 5 is 9. Okay, so I think f equals 9. And then before I move on, I want to check it to make sure that I'm right. So my original equation, replace the variable with what I think the answer is, and then simplify to see if it makes a true statement. 5 times 9 is 45. Bring down your equals, bring down your 45. That's a true statement, so you know that 9 is the right answer. Okay, let's move on to the next one. It says g plus 7 equals 49. So draw a line down. How do you get g by itself? You want to subtract 7. Whatever you do to one side, you have to do to the other. Now those cancel because 7 minus 7 is 0, and g plus 0 is just g. On this side, 49 minus 7 is 42. So I think g equals 42. To check myself, write your original, substitute in what you think the answer is, and then simplify. 42 plus 7 is 49. Bring down the equals, bring down that 49. True statement, so then you know 42 is the right answer. Again, this one is another multiplication one. The inverse of multiplication is division. So divide by the number in front of the variable. And whatever you do to one side, do to the other. 12 divided by 12 is 1. 1 times h is just h. On this side, 156 divided by 12, I don't know. I'm going to have to check. I'm going to have to do some long division. So 12 goes into 1 0 times, but 12 goes into 15 once. And 15 minus 12 is 3. Bring down the 6. 12 goes into 36 3 times. So 12 goes into 156 13 times. And in case you're very self-conscious, you're like, oof, I'm not that strong on long division. I should probably check myself. Okay, so you have 12 times you think 13 equals 156. Let's see. Okay, equals 156. Let's see what 12 times 13 does indeed equal 156. Well, 2 times 3 is 6. 3 times 1 is 3. And then I move on to this number in the tens place, so put a 0 placement holder. 1 times 2 is 2. 1 times 1 is 1. Now add down, that's 6. 3 and 2 make 5. Bring down the 1. And that is indeed 156, which makes a true statement. So you can be like, yes, okay, I did my long division right. 13 is the right answer. Okay, this is a division problem, so let's rewrite it as a fraction. And then the inverse of dividing is to multiply. Whatever you do to one side, do to the other. Those cross cancel, become 1. 1 times k is just k. And then 16 times 4, well, that's 4 plus 2 is 6, so 64. I think k equals 64. So then check it. K divided by 4 equals 16 was the original. So 64 divided by 4 should equal 16. Okay, let's see. 4 into 64. Well, 4 goes into 6 once. Subtract that, you get 2. Bring down the 4. And 4 goes into 24 6 times. So then 64 divided by 4 is 16. Bring down my equals, bring down my 16. Whew, true statement. So that was right. Okay, for my next one, you want to get rid of this minus 4 to isolate your variable. So the inverse of minus 4 is to add 4. Whatever you do to one side, do to the other. Those cancel, so you have m equals, well, 7 plus 4 is 11. 1 and 3 make 4. So m equals 41. And then let's check. M minus 4 equals 37. Plug in what you think the answer is. And let's see, 41 minus 4. If I were to simplify that, borrow. 11 minus 4 is 7. Bring down your 3, and you get 37. Bring down the equal sign. Bring down the 37. That's a true statement, so 41 was right. Okay. Now we're going to turn these word phrases into either equations or expressions. This says 7 less than, okay, so 7 less than means minus 7. What am I subtracting 7 from? The quotient, so I'm dividing something. The quotient of some number that we don't know, and 3. Okay, so that would be the expression for that particular word phrase. Now notice that it didn't have an equal sign and it wasn't an inequality because it didn't have the word is. I want to point 2 things out. If it said 7 is less than the quotient of a number and 3, it would be 7, and then is a form of an equal sign, but it said is less than, so it's an inequality. It's a less than sign, right? And 7 is less than the quotient of a number and 3. So if it was written like this, that would be what I would write. If it said just 7 less the quotient of a number and da 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 da. Okay, so it didn't say is, so it's not an equal sign or inequality. And it didn't say less than, so it didn't move it to the back. This is another expression, and it would be 7 less, so just minus, because it's not less than moves it to the back. So 7 less the quotient of a number and 3. Okay, and if you're like, I don't see the difference between those, let me just write it with less words for you down here at the bottom, the difference between the 3. Okay, if it said 4 less than 7, okay, 4 less than 7. So there's no is, it's not an inequality type, and it's less than, so it moves the 4 to the back. So that would be minus 4, and 4 subtracted from what? A 7. Okay, so that's how that one would look. Then, if it said 4 is less than 7, okay, this is not like, a minus sign or anything now that I'm dealing with. This is a form of an equal sign or inequality. And it's not just is less than. So it's an inequality of a less than sign. And so it's 4 is less than 7. And if it said is less than or equal to, then I would put a line underneath of that inequality sign. Okay, and then the last one that's really similar to this is if it just said 4 less 7. That's just 4 minus 7. Okay, so those are the ones that always kind of tripped me up a bit. They were just way too similar. So I wanted to point out the difference between those, okay, if you want to review them. And now let's move on to number 12. It says, write the inequalities shown by the graph. So I know that I'm comparing all the numbers that the arrow is representing. So a lot of possibilities. I'm going to use a variable and 4. Okay, the arrow is going to the right. So it's all the numbers bigger than 4. So I'm going to have the great big open end facing my variable. Or since I have my variable on my left, this can be like your arrowhead. See how this matches the inequality? Your arrowhead matches the inequality sign. There you go. Now, if this circle was shaded in, there would be a line underneath because it would be including the 4. But since it's open, there's no line underneath. That's it. Okay, the next one, we're going to simplify the expression. You're like, what's that? Do you remember PEMDAS or GEMDAS? Parentheses, exponents, multiplication and division, and then addition and subtraction. So multiplication, division before addition and subtraction, but when deciding between multiplication and division, go from left to right, whatever comes first. And then when deciding between addition and subtraction, go from left to right of whatever comes first. But again, multiplication or division always comes before addition and subtraction. All right, so do you see any parentheses? No. Do you see any exponents? No. Do you see any multiplication or division? Yes. What's the first one you see of the two? Those ones. 5 times 4 is 20. Bring everything else down. And then no parentheses, no exponents, multiplication or division, right there. 10 divided by 2 is 10. 20 divided by 2 is 10. Bring down the minus 3 plus 34. And then now all there's left is addition or subtraction. So go from left to right. 34 plus 10 is 44. And now you have just 44 minus 3. And again, I know it seems silly, but at this point, I would have actually shown 34 plus 10. Because you know how sad it makes me when people get that this isn't 44. They get something wrong because they're too afraid to show that. And same thing with this. Just show. Don't try to do it in your head. And then you make a really simple error and you miss it. So 4 minus 3 is 1. Bring down your 4. You get 41. Again, don't be afraid to show the little addition or subtraction off to the side if needed so you don't miss something simple. Okay, number 14. Things are starting to blur together. I'm going to use a different color. Okay, brackets are a form of parentheses. So I'm going to focus on the brackets. And then within the brackets, order of operations still apply. So do you see any parentheses? Yep. So within the parentheses, order of operations still apply. So what would you do first? Subtraction or division? Division. 15 divided by 3 is 5. Bring down the minus. 12, that's in parentheses, which is all inside of a bracket. Plus 3, another bracket, and squared. All right. Okay, so I'm within there. And then within there, I still have those parentheses. 12 minus 5 is 7. Bring down the plus 3. There's your brackets and a squared. Okay, if you want to have that in parentheses, it's fine. They could have dropped away now because it was down to a single number, but if you want to, it can, or if you want to drop them away. Okay, but I still have those brackets. 7 plus 3 is 10. Now I got within the brackets to a single number. So now I can square this because it's this whole thing that's being squared, not just the 3, the whole thing inside of here. 10 squared is 100. All right, let's go ahead and turn the page. We've almost cranked out this whole study guide. How are you doing so far? Have you been getting most of them right? Okay, this one wants us to graph. T is, what is that? Say it before I do. T is less than 18, okay? So then, is it an open or closed circle at 18? Hopefully you said open. And then which way should it go? Should it go to the left or to the right? Well, it's less than, right? The little tiny dot end is facing the variable. So numbers get smaller going to the left. Or since my variable is on the left, this is kind of like your arrowhead. This inequality sign matches the arrowhead of where it's going, right? Okay. Word problems, the best kind. All right, Mike has 12 puppy toys. He wants to give each of his puppies an equal number of toys. He gives each puppy 3 toys. How many puppies does Mike have? Write an equation using P to represent the number of puppies Mike has. And so really make sure, like, always match the variable that they're using. So it wants a capital P to represent the number of puppies Mike has. Why don't you go ahead and try to set up that equation? Okay, and if you need to, you can pause it. But now that you're back with us, hopefully, I would do, he has 12 puppies, and each one gets 3 toys. Or sorry, he has 12 puppy toys, and he gives each puppy 3 of them. So then that's going to be equal to the number of puppies that he has. Okay, that's probably what makes the most sense to me. You could have also done it this way. This is saying the same thing, but you want to stay away from using equations that have your variable in the bottom because we don't know how to solve those just yet. And even when you do learn them next year, they're still a little bit tricky. So if possible, try to avoid having your variable in the bottom. Okay, but I mean, it is still correct. So if it was one of the multiple choice options, yes, that way works. But then there's always, more than one way to do it. What's the inverse of division? Multiplication. So how would this have looked multiplication wise? It would be these 2 guys multiplied together to equal that top number of 12, right? So the number of puppy toys times the number of puppies equals the total number of puppy toys. Okay, the number of puppy toys each puppy gets times the total number of puppies that you have equals the total number of puppy toys. Either of those equations would have worked. I would try to avoid using this one if you're going to solve it yourself. Okay. So let's do, if you got this one as your equation, just simplify it. There's no isolating the variable. It's already isolated. So just simplify this side. 12 divided by 3 is 4. That means there was 4 puppies. Okay. Or if you did it this way, then the variable does need to be isolated. And so to get it by itself, the inverse of multiplying is to divide by 3. And now those cancel. 3 divided by 3 is 1. So you have 1 times P, which is just P. Whatever you do to one side, do to the other. 12 divided by 3 is 4. So whether you thought of it as a division problem, 12 divided by 3, or a multiplication problem, 3P equals 12, you still get Mike has 4 puppies. All right, our next one. Ava had $27 on a gift card. She spent X amount at the store. She has 14 left on the gift card. Write an equation using X to represent how much money Ava spent at the store. The one that makes the most sense to me is she has 27. She spent X, so minus however much you spent, which was X, is equal to how much she now has, which is 14. Okay, or some people say, well, if whatever she has left plus however much she spent equals how much she started with. Okay, that way works too. Now the same thing as this is X plus 14 equals 27. Okay, because some people wrote it this way. That's the same exact thing as that one. For this one, this is how I think of it, but I don't like it because you shouldn't have, just remember before how I said you shouldn't have your variable in the denominator. You also, if possible, should avoid having X be negative because it's a little bit tricky. So if possible, if you could rewrite it without X being negative, that would be great. So isn't this saying the same thing? 27 minus 14 equals X, right? Isn't that the same thing as this? And then you don't have a negative X. And this is why. Let's say that I did it this way. Next year, you're going to see, when you have a negative variable, bring it over to the other side to make it positive. So add that whole thing over to this side. Now these cancel, right? X minus X is 0. and you have 27 equals, now you have 14 plus x over here, which is essentially what that equation is. And then to get x by itself, you would subtract 14, and 27 minus 14 is 13 equals, those cancel, x. So you have, she spent 13 at the store. That was like an extra added step that I just don't like to do. So I would say do this one, 27 minus 14 equals x. And then as you can see, you just immediately dive in. The variable's already isolated, and 27 minus 14 is 13. Done. Okay, or even if you do one of these, 14 plus x equals 27. It's just one step instead of two steps over here. To get x by itself, you get rid of that 14. Those cancel, and you have x equals, because x plus 0 is just x. Whatever you do to one side, do to the other, and you get 13. All the ways we got 13, but this one probably looks super hard because you don't know how to do it yet, really. I mean, it's doable, but we're learning about this next year. So please try to avoid having the x be negative if possible, okay? And try to use one of the other types of equations. But regardless, you still get, she spent $13 at the store. All right, and hopefully you did pretty well on those. Remember, really practice showing the inverse steps, as that's where most of your points are coming from. And if you did them all right, even the steps, congratulations, my little mathematicians, you've got this.